A language model trained on data from last year cannot tell you what happened this morning. But with a web search tool, it can. In this episode, we build an MCP server that connects Claude to the Brave Search API. Claude can now search the web in real time, read the top results, and cite its sources. This is one of the highest value MCP tools you can give any language model. We use the Brave Search API because it has a generous free tier of 2,000 queries per month, returns clean structured JSON, and has a simple one endpoint design. If you prefer a different search provider like Serper, SERP API, or Tavily, the server pattern is identical. The only things that change are the base URL, the header format, and the JSON field names in the response. Everything else stays the same. We install two packages, MCP for the server and HTTPX for async HTTP requests. We read the Brave API key from an environment variable and store the base URL as a constant. Using HTTPX instead of request is important here because our MCP server is async. Calling the synchronous request library from an async context would block the event loop. HTTPX provides the same interface but works correctly with async and await. The search tool handler takes a query string and an optional count argument defaulting to 5 results. We open an async HTTP client, send a GET request to the Brave endpoint with the API key in the header and the query parameters, and raise for status to catch any HTTP errors immediately. The response JSON has a web key containing a results array. We extract that array for formatting in the next step. We format each result as a numbered citation block. The citation number in square brackets lets the model reference specific sources in its answer. It can say according to source 2 and include the URL. The title gives the model context about what the page is. The snippet is the search engine summary of the page content. Separating results with double new lines makes the structure easy for the model to parse and reason about individually. We wrap the search logic in a try-except that handles 2 error types. HTTP status error catches 400 and 500 responses from the API, such as an invalid key or a rate limit hit. We include the status code and the first 200 characters of the response body in the error message so the model can explain what went wrong. Request error catches network failures like timeouts or DNS errors. Both error types raise value error, which the MCP client returns to the model as an error response. The description tells the model exactly when to use this tool. The phrase used for recent events or anything that may have changed since training is important. It tells the model to reach for this tool whenever it is uncertain whether its training data is current. The count argument has a default of 5 and a maximum of 10. Setting a maximum prevents the model from requesting an unreasonably large number of results, which would blow up the context window. We add the server to the Claude Desktop config and pass the Brave API key through the environment object. Never hardcode API keys in the server file itself. The environment field in the config is the right place for secrets because the config file lives outside your code repository. Restart Claude Desktop and ask Claude what the top AI news stories are today. Watch it call the search tool, read the results, and answer with numbered citations pointing to the source URL. You now have a web search server that gives Claude real-time access to the internet with numbered citations. In the next episode, we build an API wrapper server. We take any REST API, wrap it as a set of MCP tools, and expose it to Claude without the model ever needing to know the URL structure or authentication method. Subscribe so you do not miss it. See you in the next one.